Imagine standing at the very end of everything familiar, at a point in time so distant that every star currently twinkling in tonight's sky has already burned out, gone dark, or collapsed into something unrecognizable. Now imagine that somewhere in that unimaginably distant future, a small, silent object built by human hands in the 1970s is still moving, still intact, still carrying a golden record loaded with greetings in 55 languages and the sound of human laughter. That's not science fiction. That's an actual calculated projection, built by real astrophysicists using real orbital mechanics, describing where Voyager 1 could plausibly still be in 10 trillion years. This is a genuine exploration of Voyager 1's deep future, built entirely on published, peer-reviewed research from scientists who have specifically studied this exact question. And I want to walk through it the way the researchers themselves actually built it, one calculated milestone at a time, working outward from the present toward a timescale almost too vast to properly hold in your head. Right now, in 2026, Voyager 1 sits a little over 15 billion miles from Earth, moving at roughly 38,000 miles an hour, coasting on momentum it picked up from its final gravity assist at Saturn back in November of 1980. It has no fuel remaining for any further major course correction, no way to steer, no way to slow down or speed up in any meaningful sense. Whatever direction that final flyby happened to send it is, for all practical purposes, the direction it's going to keep traveling for the rest of its existence, for as long as that existence continues. The first genuinely calculated milestone in Voyager 1's future arrives remarkably soon, at least by the standards of everything else in this video. NASA's own trajectory data shows Voyager 1 heading generally toward the constellation Ophiuchus, on a path that will eventually carry it within roughly 6 light years of a small red dwarf star called Gliese 445, currently sitting in the constellation Camelopardalis. That encounter is projected to occur in approximately 40,000 years. 40,000 years sounds enormous until you place it next to everything else in this story. But it's worth remembering just how long a stretch of time that actually represents in human terms. 40,000 years ago, our own species hadn't yet developed agriculture, writing, or permanent settlements. We were still, as a species, hunting, gathering, and slowly spreading across the planet. And that's merely the closest, nearest term checkpoint in Voyager 1's calculated future. Push the timeline out considerably further to roughly 1 billion years from now, and you reach a genuinely different kind of milestone, one calculated not by tracking Voyager 1's path toward any single nearby star, but by modeling its entire orbit around the center of the Milky Way galaxy itself. Astrophysicist Avi Loeb, working with his student Shokruz Kakarov at Harvard, built detailed models of the Milky Way's overall mass distribution, specifically to plot exactly where Voyager 1's orbit would carry it over that kind of timescale. Their calculations showed that within roughly 1 billion years, Voyager 1 will have traveled all the way to the opposite side of the galaxy's disk, relative to where our own sun currently sits, completing what amounts to a significant portion of a full galactic orbit. Loeb pointed out something worth sitting with about the timing of that particular milestone. By the time Voyager 1 actually reaches that point in its journey, our own sun will already have expanded enough during its own aging process to boil away Earth's oceans entirely, rendering our home planet uninhabitable roughly 1 billion years from now. Whatever happens to Voyager 1 at that specific moment, there won't be anyone left on Earth to mark the occasion, even if they somehow wanted to. Keep going out to roughly 4.5 billion years from now, and you arrive at one of the genuinely significant, well-established events in our galaxy's actual future, the eventual collision and merger between the Milky Way and the neighboring Andromeda galaxy. This isn't speculative. Astronomers have tracked Andromeda's motion relative to our own galaxies for decades, and have a high degree of confidence that this merger will actually happen, roughly on this timescale. Nick Oberg, a doctoral candidate at the Captain Astronomical Institute in the Netherlands, presented detailed research specifically addressing what might happen to both Voyager spacecraft and the golden records they each carry across an event of this scale at the 237th meeting of the American Astronomical Society in January of 2021. Oberg's team calculated that in the roughly 5 billion year window leading up to that eventual merger, each Voyager spacecraft would likely pass within about 150 times the distance between the Earth and the Sun of at least one other star, roughly 3 times the distance separating our own Sun from Pluto at its most distant point. There's a genuinely strange detail buried inside that specific calculation, one Oberg himself pointed out directly. Because researchers are projecting so far into the future, the specific star involved in that eventual close encounter might not actually exist yet, even as of right now. Voyager 1 could plausibly, according to this research, eventually pass near a star that hasn't been born as of today, a star that will only form sometime between now and that projected encounter, out of gas and dust that hasn't even finished collapsing into a new stellar system yet. Here's where the story starts to move into territory that's genuinely difficult to fully comprehend, Because once the Milky Way and Andromeda actually finish merging into a single combined galaxy, Voyager 1's fate becomes tied to something researchers can only estimate with real, acknowledged uncertainty. Exactly how much interstellar dust and gas remains scattered throughout that newly merged galactic structure going forward. As stars across the combined galaxy gradually exhaust their available nuclear fuel, and as the overall rate of new star formation slows and eventually grinds to a halt entirely, the total amount of dust and gas drifting through the galaxy is expected to steadily, gradually decline as well, star by star, cloud by cloud, over a span of time that dwarfs everything discussed so far in this video. Oberg explained that, depending on precisely how that dust environment continues evolving, Voyager 1 and Voyager 2 might actually be able to survive, drifting essentially undisturbed through the newly merged galaxy for what he described in his own words as trillions of trillions of trillions of years. That's not a typo, and it's not hyperbole. It's the actual language used in describing a legitimate, calculated scientific projection. Such a distant point in time, Oberg noted, sits far beyond the era where stars still actively burn nuclear fuel at all. Star formation across the entire universe, not just our own galaxy, will have ceased in its entirety by then, and the Voyagers would be drifting through a version of the galaxy populated almost exclusively by black holes and various forms of stellar remnants, white dwarfs and neutron stars, the cold, quiet, burned-out leftovers of stars that finished their active lives long, long before that point in cosmic history. Now, let's actually address the specific number the question asks about, 10 trillion years, because it occupies a genuinely interesting and scientifically meaningful position within this larger timeline. 10 trillion years sits well within what astrophysicists studying the deep future of the universe, particularly Fred Adams and Gregory Laughlin in their widely cited research on cosmological timescales, describe as the tail end of what's formally called the Stelliferous Era, the period during which stars across the universe actively form and burn nuclear fuel in any meaningful, widespread way. Current estimates suggest ordinary star formation throughout the universe will have almost entirely ceased by around 100 trillion years from now, meaning at the specific 10 trillion year mark, Voyager 1 would already be drifting through a universe where the overwhelming majority of stars, similar to our own sun, have long since died, exhausted their fuel, and either expanded, collapsed, or exploded, depending on their original mass. Meanwhile, the smallest, most miserly stars in the universe, low-mass red dwarfs, some of which can theoretically continue burning fuel for trillions of years due to how slowly and efficiently they consume their limited hydrogen supply, might still be flickering here and there across an increasingly dark, increasingly sparse galactic landscape, the last remaining embers of a universe that once blazed with far more active starlight. So what would Voyager 1 actually physically be doing at that specific 10 trillion year mark? Almost certainly, simply continuing to move in whatever direction its long, slow orbit around the galaxy's center happened to carry it by that point, an entirely inert, silent object with no functioning power supply, no communication capability, and no scientific instruments still capable of operating in any meaningful sense whatsoever. It's worth being honest about how small a fraction of this entire story the actual functioning Voyager mission represents. Both Voyager spacecraft are expected to lose all remaining functional power sometime in the 2030s, meaning the working, scientifically active portion of this entire narrative concludes within the next decade or so, an almost comically tiny sliver of the 10 trillion year span being discussed here. Everything that happens after that point isn't a functioning spacecraft continuing some kind of ongoing mission. It's simply a physical object, obeying the same basic laws of orbital mechanics as literally everything else drifting through the galaxy, subject to the same gravitational forces and the same statistical odds as any other piece of debris caught in a long, slow orbit around a galactic center. And those statistical odds, according to the actual research conducted on this exact question, remain remarkably favorable for Voyager 1's continued undisturbed survival across almost incomprehensible stretches of time. Researchers studying this specific question have calculated that even accounting for the eventual Milky Way-Andromeda merger and everything that follows it, the sheer overwhelming emptiness of interstellar and intergalactic space means it could take somewhere on the order of 10 to the 20th power years, roughly 100 million trillion years, before Voyager 1 would have any statistically meaningful chance of actually colliding with a star, or with any other object of significant size. Set against a number that large, 10 trillion years represents barely the earliest, opening stretch of an almost unimaginably long, quiet, largely undisturbed drift through a universe that keeps growing emptier, darker, and quieter with every passing epoch. There's a specific piece of this story that deserves genuine attention here because it connects this entire, almost overwhelming timescale back to something deeply, deliberately human. Both Voyager spacecraft carry the Golden Record, a gold-plated copper disc containing greetings recorded in 55 different languages, a wide range of natural sounds recorded here on Earth, and 90 minutes of carefully selected music representing cultures spanning the entire recorded history of our species. Carl Sagan, who led the committee responsible for actually creating and assembling the record, originally estimated it could remain physically playable for at least 1 billion years under the specific conditions found in deep space, an already staggering claim on its own. But more recent analysis, specifically the kind of careful trajectory modeling and collision risk calculation described throughout this video, suggests the record could plausibly remain intact and genuinely undamaged for a period measured in trillions of years, precisely because interstellar space turns out to be so overwhelmingly, almost incomprehensibly empty that the record faces remarkably little realistic risk of ever being destroyed by an actual damaging collision with anything at all. It's worth pausing to appreciate just how much genuine, careful science actually underpins a question that sounds, on the surface, almost absurdly speculative, more like a thought experiment than a real research topic. Nobody involved in this work is simply guessing wildly or throwing out impressive-sounding numbers for effect. Every figure discussed in this video traces directly back to real orbital mechanics, real published models of the galaxy's overall mass distribution, and real peer-reviewed research presented at legitimate scientific conferences and published in respected journals, all of it extended forward using the exact same fundamental physics that lets astronomers reliably predict eclipses, planetary positions, and spacecraft trajectories decades or centuries in advance, here simply applied across an almost inconceivably longer timescale than usual. So here's what I actually want you to take away from all of this. In 10 trillion years, based on real, published, scientifically grounded modeling, Voyager 1 will almost certainly still exist, still drifting through whatever the Milky Way, or its eventual merger with Andromeda, has become by that point in cosmic history, very possibly still carrying a golden record that remains perfectly intact, still capable, at least in principle, of being played by anyone or anything that ever happens to encounter it. Every star currently visible in tonight's sky will likely be gone by then, replaced by black holes, white dwarfs, and the last, faintly flickering embers of the universe's smallest, longest-lived stars. Earth itself will have been completely uninhabitable for essentially the entire span of that 10 trillion-year journey, boiled dry by our own sun's aging process long before Voyager 1 ever reaches even the earliest checkpoints described in this video. And Voyager 1, a machine our own species built and launched during the presidency of Jimmy Carter, using less computing power than a modern calculator, will simply still be out there, moving, silent, carrying a message that was never really meant to be read anytime soon, patiently waiting across a length of time that dwarfs the entire recorded history of human civilization many, many times over, for anyone or anything that might eventually come looking. If you want to know what Scientist Project happens to Voyager 1 across even longer timescales still, all the way out toward the eventual heat death of the universe itself, subscribe and turn on notifications, because that specific research genuinely exists too. And if you thought 10 trillion years was difficult to wrap your head around, it only gets stranger from here. And drop a comment telling me whether you think anyone or anything out there in the depths of space ever actually finds either Voyager before that 10 trillion year mark eventually arrives, because after working carefully through these numbers, I think the honest odds are considerably longer and considerably stranger than most people would ever initially guess.